Welcome back. Tonight we're going to be solving quadratic equations by graphing. We do know how to graph quadratic functions, and tonight we're going to take that a step further and solve those quadratic equations. So first we have to understand the difference between a function and an equation. A quadratic function is related to a quadratic equation by replacing the y with a 0. So a quadratic equation is this same quadratic function, but written instead of with a y, with a 0. So, quadratic equation, just like the definition we had before, is an equation that can be written in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and remember that a cannot be equal to 0. If I have no a term, I just have a linear equation, this time instead of a function. Means we're going to solve a quadratic equation in standard form by finding the x values where y is equal to 0. In other words, we are looking for the zeros of the function. So here is a graph of a quadratic function. I've got zeros here at 3, 0, so my y value is 0, and at -1, 0. Okay, remember, if you would like to be using your computer to try to mimic this on the quadratic calculator that we were using in class, you can go to this website and pull up the quadratic calculator that we were using so you can see what these look like. Okay, so we're going to go ahead and solve a quadratic equation by graphing. In order to do that, the first thing we're going to do is write the related function. So remember, the function is just where this is equal to y. So I've got y equals -x squared plus 4. Next, I'm going to graph the function. So I'm going to have to find my normal points that I would look for. So my axis of symmetry, of course, is going to be at x equals 0. I've got a vertex at 0, 4. And I could pick some other points to graph. I've got -2, -1, 0, 1, and 2. And those values are going to be 0, 3, 4, 3, and 0. So I'm going to go ahead and graph those really quickly. Okay, and while not beautiful, you remember that this makes a lot of sense. I've got a negative a, therefore this is going to be a frowny face parabola. And you remember where these points are for my axis of symmetry and my vertex. And I could have graphed a multitude of points, but I chose these and they were easy. And it turns out that I was readily able to find the zeros of this function. I've got zeros here at 2 and at -2. So the zeros are the solution to this equation. So therefore, where y equals 0 at 2 and -2. Okay? Okay. So this one's going to be a little more complicated. I'm going to go ahead and solve this one by graphing. Remember, the first thing I'm going to do is write the related function. So of course that's going to be y equals 2x squared minus 3x minus 5. Then I will graph the function. I'm going to need to find all those points in order to graph it. I've got a axis of symmetry at 3/4, which is not going to be pretty, but my vertex is also not going to be pretty. I've got a vertex that's at 3/4 and -6.125. So we can already tell this is not going to be easy to graph by hand. So let's go ahead and grab our calculators to graph this properly and find the zeros, which will be the solution to this quadratic. So our goal, of course, is to find the zeros. So what I'm going to do here is I'm going to I'm going to use my calculator, and in class I can show you how to download this emulator, but I'm going to plug in my equation into my y equals. I've got 2x squared minus 3x minus 5. Okay, so I can graph this and see what it looks like. Now I can see already I've got zeros right here and right here, and I might be able to guess where those are, but I can definitely tell if I go to my table. Well, I already had my table set. Let's go back and look at the table set. I had my table set at 0, and I had a change of 0.5 because it's going to turn out that one of my zeros is at a half. So going back to my table, notice I have a 0 here at 2.5, but I've not yet gotten to 0. So there is my other 0. So the zeros for this graph, and I'll go back to my graph, are at -1 and 2.5. So let's go back to the graph, and I can see that my zeros are here at -1 and 2.5, which I saw in my table. Goes in for this function, which we just saw in the calculator, my zeros were at -1 and 2.5. So I'm going to solve this one also by using my calculator, but first I'm going to look at a little bit of the logic of it by finding some of the relevant points. Notice I'm first going to have to put this in standard form. Standard form would be x squared minus 3x plus 4 equals 0. And to graph, I would have to make this into a quadratic function. So y equals x squared minus 3x plus 4. If I found the axis of symmetry, I would see that it was at x equals 3/2, and my vertex is going to be at the point 3/2 and 7/4. So notice my vertex is going to be somewhere around 1.5 and 1 3/4. Notice I've got a positive A, so I know that I've got a smiley face parabola, wherever that might be, and we'll look at the graph on the calculator in a second. But what do we know about our zeros? If this is going something like this, my zeros are non-existent. I have no real zeros. Any zeros because it never touches the x-axis. So let's go ahead and see what that looks like on our calculator. So I'm going to plug in my equation. I've got x squared minus 3x plus 4, and I'm going to go ahead and graph that function. And it's exactly what we expected. We've got a smiley face parabola with a vertex that is a minimum, and it's above my x-axis. Therefore, I have no real zeros. So I can take a look at my table and confirm that I got to a minimum point, which on here looks like 1.5, 1 3/4, which is actually exactly the number we came up with, and then it's getting bigger again. So my minimum point was here, and I never had a y value of 0. So in fact, I have no real solutions to this equation. Let's look at a application problem. I've got a flying fish jumping out of the water, and I've got a quadratic function y equals -16x squared plus 12x that models the fish's height above the water after x seconds. And I want to know how long the flying fish is going to be out of the water. Well, we're going to use a calculator to calculate this, but let's first think about how I would find out how long the fish is out of the water. Well, first I'm going to need to find the x-intercepts because my x is the number of seconds, the distance between the distance between my x-intercepts is going to be the time that the fish is out of the water. If you have a calculator, go ahead and set your table to increments of 0.25 in order to find the solution to this. I'm going to go ahead and grab a calculator. Okay, so I've plugged in my function, y equals negative 16x squared plus 12x. I'm going to go ahead and graph it, but first I'm going to want to change my window. I know that I'm not going to have, remember x equals time, I'm not going to have seconds that are negative, so I'm going to want to start at 0. I think that I might want, I'm pretty sure my fish isn't going to be in the water, in the air too long. So I think I might change this to 5 just to see. And I did tell you that you're going to want to set your change in x to 0.25 in order to see enough of the change. And I don't know that I care about my y values for right now because that's just telling me the height. So let's go ahead and take a look at our graph and see if this looks like what we want. That looks pretty good. I can absolutely see my zeros here and here, and I can see the vertex, the height, the highest point that the fish got, but our interest today is how long it was out of the water, and that's going to be the distance between these two zeros. So let's go ahead and look at our table. Remember, we're going to have to set our table so that we can see, first of all, it's going to start at 0, and we're going to want our change to be 0.25. Now we can check our table. And we can see we had a 0 here at 0, and then our next 0 was there at 0.75. So we know that the fish was out of the water for 0.75 seconds. Okay, so now we know by using our calculator that the fish was out of the water for 0.75 seconds. All right, so I want you to go ahead and graph these. You can do them by hand, or if you have a calculator, you can use that. And you've got one application problem, but before you go, I've got a joke for you. Why didn't the number 4 get into the disco? Because he was too square. All right, I'll see you in class tomorrow.